Hi students, today we are going to discuss another important topic for NEET and JEE from the chapter chemical bonding. In previous video we discussed about the ionic character in covalent bonding, that is polarity in covalent bonding. Now here we are going to discuss the covalent character in ionic bonding, that is explained by Fajan's rule, that we are going to discuss today. ഇന്ന് നമ്മൾ പറയാൻ പോകുന്നത് കഴിഞ്ഞ വീഡിയോയിൽ നമ്മൾ കോവലന്റ് ബോണ്ടിലെ അയോണിക് ക്യാരക്ടറിനെ കുറിച്ച് ഡിസ്കസ് ചെയ്തു. ഇന്ന് നമ്മൾക്ക് പറയേണ്ടത് അയോണിക് ബോണ്ടിലെ കോവലന്റ് ക്യാരക്ടറിനാണ്. അത് എക്സ്പ്ലെയിൻ ചെയ്യുന്ന റൂളാണ് ഫജാൻസ് റൂൾ. ദാറ്റ് ഈസ് വെരി ഈസി റൂൾ, very easy method. Okay, we can explain. Let us see how it is. We know that every ionic bond have some covalent character as well as every covalent bond have some ionic character. No bond 100% ionic, 100% covalent. Already the ionic character of the covalent bond we discussed in the previous video. Here we are going to discuss the the covalent character of ionic bond, that is explained by Fajan's rule. Okay, so in Fajan's rule, see what happens. For example, in a ionic solid or ionic bond, this is cation, we have an anion. Okay, we have an anion. In this anion we have negative charge, that is electrons are there. Okay, so when this anion and cation comes close together, what happens? This electronic cloud, that is electronic cloud of the anion, shift towards this cation. That means there is a distortion in the electronic cloud. There is a distortion in the electronic cloud of anion. It becomes somewhat like this. That is, electron cloud will shift towards what? Actually, it was spherical, but it is shifting towards cation. Okay, so the distortion of the electronic cloud happens in anion. That means the electron is shifting to the center. Actually, in a covalent bond, we know that suppose if it is hydrogen, the shared pair of electron remain at the center. But in ionic bond, one complete, for example, in NaCl 281, Cl 287, atomic number 17, total 17 electron. Here it is atomic number 11, total 11 electron. This one electron shift to Cl. Therefore, what happens? Na plus and Cl minus. This is an ionic bond, positive and negative charge. Now, in this Cl minus, some electron will shift to the center. So it gets some sort of covalent character. Okay, so due to the distortion of this electronic cloud, the electrons shift to the center. Therefore, this bond gets some covalent character. Okay, so this is explained by Fajan's rule. This distortion is called polarization. Due to this polarization, some extent of sharing of electron occur between two ions and get somewhat covalent character. Okay, due to this polarization, some extent of sharing of electron occur between two atoms and it gets some covalent character. അതായത് ഈ ഒരു പോളറൈസേഷൻ കൊണ്ട് ഒരു ചെറിയ ഷെയറിംഗ് ഓഫ് ഇലക്ട്രോൺ എന്ന് പറഞ്ഞാൽ എന്താണ്, ഈ മിഡിലേക്ക് കുറച്ച് ഇലക്ട്രോൺ എന്ത് ചെയ്യും, നീങ്ങി വരും. അതുകൊണ്ട് ഈ ബോണ്ടിന് ചെറിയ എന്ത് കിട്ടും, കോവലന്റ് ക്യാരക്ടർ കിട്ടും. ഓക്കെ, സോ ദ കോവലന്റ് ക്യാരക്ടർ ഓഫ് ദിസ് മോളിക്യൂൾ ഡിപ്പെൻഡ്സ് ഓൺ the polarizing power of cation. That means this polarizing power, that means this is getting polarized. That means all the negative electron is shifting to this side, that is called and nucleus, and positive charge on that side. So this anion is getting polarized. So that distortion or this covalent character depends on two factors. First factor, polarizing power of cation. Second factor, polarizability, that the ease with which an anion can be polarized, that is called polarizability. The covalent character of an ionic bond depends on two factors. First factor is polarizing power of cation. That means the power, the ability to distort the electronic cloud of anion. Similarly, the polarizability of anion, that means the ease with which the electronic cloud of anion is getting polarized. അതായത് ഒരു അയോണിക് ബോണ്ടിൽ കോവലന്റ് ക്യാരക്ടർ എന്തിനാണ് ഡിപ്പെൻഡ് ചെയ്യുന്ന രണ്ട് കാര്യങ്ങളാണ്. ഒന്ന് കാറ്റയോണിൻ്റെ പോളറൈസിങ് പവറിനെയാണ്, രണ്ടാമത്തത് ആനയോണിൻ്റെ പോളറൈസ് ചെയ്യാനുള്ള ഈസിനെസ്, അതായത് എത്ര പെട്ടെന്ന് അത് ആനയോൺ എന്ത് ചെയ്യും പോളറൈസ് ചെയ്യപ്പെടും എന്നതിനെയും, പിന്നെ കാറ്റോൺ എത്രത്തോളം പോളറൈസ് ചെയ്യാനുള്ള, അതായത് ഇലക്ട്രോണിനെ ഇങ്ങോട്ട് വലിക്കാനുള്ള പവർ ഉണ്ട് എന്നതിനും ഡിപ്പെൻഡ് ചെയ്യുന്നുണ്ട്. ദ പോളറൈസിംഗ് പവർ ഓഫ് കാറ്റോൺ അഗൈൻ ഡിപ്പെൻഡ്സ് ഓൺ ത്രീ ഫാക്ടർ. വാട്ട് ആർ ദ ത്രീ ഫാക്ടർ? സൈസ് ഓഫ് കാറ്റോൺ, ചാർജ് ഓഫ് കാറ്റോൺ and pseudo noble gas configuration of cation. We will discuss one by one. Now the polarizability of anion size also depends on two factors: size of anion and charge of anion. Okay, so higher the polarizing power of cation, higher will be the covalent character of an ionic bond. Higher the polarizability of an anion, that means the anion is very easy to get polarized, then also the covalent character of ionic bond will be very high. Okay, so we can discuss one by one. So first we are going to discuss the polarizing power of cation. Let us discuss the polarizing power of cation. It depends on the three factors: size of cation, charge of cation and the pseudo noble gas configuration. So the first factor, size of cation. Smaller the size of cation, higher will be the pulling power, that is polarizing power. If the cation is small, it can pull the electronic cloud of the anion effectively. So the smaller the size of cation, higher will be the pulling power. Okay, for example, in first group we know that ions are Li plus, sodium plus, first group elements, potassium plus, then rubidium plus. We know that down the group size increases. So which one have higher pulling power? Smaller the size, higher will be the polarizing power. Okay, so smaller the size, higher polarizing power. Smaller the size, higher the polarizing power. So which one have higher polarizing power? Lithium have higher polarizing power. Okay, so higher the polarizing power, higher will be the covalent character. So LiCl, NaCl, KCl, rubidium chloride. Which one have higher covalent character? Smaller the anion, all are same. We are not going to discuss about anion now. Now we are discussing about what? Cation. So see, anion all are same, chloride ion, but cation lithium, sodium, potassium, rubidium. Which one has smaller size? Lithium has smaller size, so higher polarizing power, therefore covalent character will be high. So this compound will be more covalent. Okay, so the covalent character here what? Decreases. Covalent character decreases. Okay, ionic character, covalent character decreases means which one have high covalent character? LiCl have high covalent character, rubidium chloride have what? Least covalent character. So okay, so covalent character decreases, at the same time ionic character what? Increases. So okay, ionic character, covalent character decreases down the group. Then down the group what happens? Ionic character increases. So which is more covalent? This one is more covalent than sodium chloride, than potassium chloride, than rubidium chloride. Which is higher ionic character? Rubidium chloride have high ionic character than potassium chloride, than sodium chloride, than lithium chloride. So this is what? Size. So we can say that size decreases, polarizing power, size decreases, polarizing power increases, covalent character increases, ionic character decreases. This is first. Next, charge of the cation. Charge of the cation. Okay, Next we can discuss charge of the cation. See, higher the charge, higher the positive charge, stronger will be the pulling. Stronger will be the pulling. It can pull the anion strongly. So distortion will be what? Maximum. If maximum distortion, maximum electron shift to the center, maximum will be the covalent character. Okay. So charge of the cation. For example, charge. For example, we have what? Na plus we have, Mg2 plus we have. Which one have high charge? Magnesium have what? High charge. So higher the charge, higher the polarizing power. Higher will be the covalent character. So if we take NaCl as well as MgCl2, which will be more covalent? Higher the charge, higher will be the polarizing power, then higher will be the covalent character. So in this case, MgCl2 will be what? More covalent than what? NaCl. Okay. NaCl will be what? More ionic than what? MgCl2. So next point, charge. Charge increases, polarizing power increases, covalent character increases, ionic character decreases. Okay. Charge increases, then polarizing power increases. When polarizing power of the cation increases, covalent character increases, ionic character decreases. Remember that. Two factors we discussed. First one, size of cation. Second one, charge of cation. Then third one, pseudo noble gas configuration. Pseudo noble gas configuration. Pseudo noble gas configuration. Third point, pseudo noble gas configuration. See, we know that what is noble gas configuration? Noble gas configuration. Noble gas configuration is what? NS2NP6. Pseudo noble gas configuration means what? NS2NP6ND10. That is total, in the last shell 18 electrons will be there. That is what? Pseudo noble gas configuration. So if pseudo noble gas configuration have in a metal or in a cation that have high polarizing power, therefore the covalent character will be more. Pseudo noble gas configuration, higher will be the polarizing power, then higher will be the covalent character, least will be what? Ionic character. For example, we can take an example. See, copper atomic number is 29. Electronic configuration, we know that 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. In copper plus 1, it will be what? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. That means ns2, np6, nd10. You can see here ns2, np6, nd10. So in copper chloride, CuCl, cuprous chloride. In cuprous chloride, chlorine is -1, copper is what? +1. So in +1 oxidation state, what is the electronic configuration? NS2, NP6, ND10. So this copper here, cuprous ion have what configuration? Pseudo noble gas configuration. So this one have high polarizing power. This copper +1 ion have high polarizing power. Therefore, this bond or this compound have what? High covalent character. For example, if you have NaCl and CuCl, which one will have high covalent character? Cuprous chloride have high covalent character. Actually here it is what? +1, here also +1. Both the anions are what? Same. Okay, then checking about what? Cation. Cation, this one and this one, both charge is what? Same. So next we are checking what? This one have what? Pseudo noble gas configuration. Pseudo noble gas configuration, high polarizing power, therefore higher covalent character. Similarly, below the copper, in periodic table, below the copper we have what? Copper atomic number 29. Another one what? Silver. Silver atomic number 47. Another one gold atomic number 79. In all these cases, Cu plus what? Pseudo noble gas configuration. Here the electronic configuration will be what? Here copper what? 3s2, 3p6, 3d10. Then here it will be what? 4s2, 4p6, 4d10. Ag plus. Here copper plus. Then here it is what? 5s2, 5p6, 5d10. So all these have what? Pseudo noble gas configuration. So they are having high polarizing power and high covalent character. Okay, so this is what? Pseudo noble gas configuration. So next example for this category is what? Zinc. Zinc, we know that electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. So zinc 2 plus. Zinc 2 plus will be what? 3s2, 3p6, 3d10. Again what? ns2, np6, nd10. Just below zinc in periodic table we know that which element it is? Zinc cadmium. Cadmium 2 plus. It will be what? 4s2, 4p6, 4d10. Okay, next just below that mercury 2 plus. It will be what? 5s2, 5p6, 5d10. So Cu plus, then Ag plus, Au plus, Zn2 plus, Cd2 plus and Hg2 plus. These elements, the compounds, ionic compounds of these elements have high covalent character due to pseudo noble gas electronic configuration. So next factor, polarizability of anion. In polarizability of higher the polarizability of anion, higher will be the covalent character in ionic bond. Okay, now polarizability of anion depends in two factors. അയോണിൻ്റെ പൊളറിസബിലിറ്റി രണ്ട് ഫാക്ടർ എന്ത് ചെയ്യുന്നുണ്ട്? ഡിപ്പെൻഡ് ചെയ്യുന്നുണ്ട്. ഒന്നാമത്തെ ഫാക്ടർ സൈസ് ഓഫ് ആനിയോൺ. ഓക്കെ, ഹയർ ദ സൈസ് ഹയർ വിൽ ബി ദ പൊളറിസബിലിറ്റി. അതായത് ആനിയോണിൻ്റെ സൈസ് കൂടുന്തോറും പെട്ടെന്ന് നമുക്ക് എന്ത് ചെയ്യാൻ പറ്റും? പോളറൈസ് ചെയ്യാൻ പറ്റും. അങ്ങനെ പോളറൈസ് ചെയ്യാൻ പറ്റുകയാണെങ്കിൽ അതിന് കോവലൻ്റ് ക്യാരക്ടർ കൂടും. ഉദാഹരണം നോക്കാം. നോക്കൂ, NaCl, NaBr, NaI. Which one have higher covalent character? Okay, see, ഇവിടെ എല്ലാം കാറ്റയോണൊക്കെ എന്താണ്? Na plus ആണ്. Okay, we can take anion Cl minus, Br minus, I minus. We know that down the group size increases. So which one have high size? I minus have size higher than Br minus than Cl minus. So which one have high polarizability? I minus. Okay, higher the polarizability, higher the covalent character. So which one will be higher in covalent character? That is NaI have higher covalent character than NaBr greater than NaCl. Okay, ഇവിടെ അയഡിൻ എന്താണ്? സൈസ് കൂടുതലാണ്. ഏതിനേക്കാളും? ബ്രോമൈഡ് അയണിനേക്കാളും ക്ലോറൈഡ് അയണിനേക്കാളും. അതുകൊണ്ട് ഇങ്ങോട്ട് വരുമ്പോൾ കോവലൻ്റ് ക്യാരക്ടർ കൂടുന്നു, അയോണിക് ക്യാരക്ടർ കുറയുന്നു. അങ്ങോട്ട് പോകുമ്പോൾ അയോണിക് ക്യാരക്ടർ കൂടുന്നു, കോവലൻ്റ് ക്യാരക്ടർ കുറയുന്നു. That is what? Size of the anion. Then second factor, charge of the anion. Charge of the anion. Anion's charge. Okay, higher the charge of the anion, higher will be the polarizability. Okay, higher the charge of the anion, higher will be the polarizability. We can take an example, MgF2 and MgO. The charge of magnesium plus 2 cation. Now fluorine minus, here it is what? Minus 2. Okay, so here fluoride ion minus 1, here oxide ion, oxygen minus 2. Okay, so which one have higher charge? Oxygen have minus 2 charge. Higher the charge, higher the charge of anion, higher will be the polarizability. So which will be easily polarizable? Oxygen is what? More polarizable than fluoride ion. So higher the polarizability, higher will be the covalent character. Okay, so which one is more covalent? MgO is more covalent than MgF2. MgO is more covalent than MgF2. That is MgF2 is ionic. Okay, so simply we can say size increases, anion size increases. Okay, polarizability increases, covalent character increases. Now, charge increases, polarizability increases, covalent character increases. Okay, clear? So this is what polarizability of anion. Okay, so these are the factors on which the covalent character of ionic bond depends. Now, application of this covalent character in ionic bond, application of Fajan's rule. Okay, what are the application? First one, the melting point. The melting, which suppose if you get some compound, which one have higher melting point, we can predict based on this Fajan's rule. Okay, higher the covalent character, lower the melting point. Higher the covalent character increases, melting point decreases. Covalent character increases, melting point decreases. Okay, we can have some example. NaCl, MgCl2, AlCl3. In all these cases, anion is what? Same. Anion charge is also same. So we can check by cation, Mg2 plus, Al3 plus. See, sodium plus 1, plus 2, plus 3. That means when we check, we can see aluminum have higher the charge. Higher the charge, higher the polarizing power, higher the covalent character. Similarly, Na, magnesium, aluminum, all these elements are belongs to the same period. So when we move from left to right, sodium is what? Atomic number 11, this is 12, this is 13. So when we move from left to right, sodium, magnesium, Al, atomic size decreases. So smaller the size of cation, aluminum is smaller. ഈ കൂട്ടത്തിൽ ഏറ്റവും ചെറുത് ഏതാണ്? അലുമിനിയാണ്. ഏറ്റവും ചാർജ് കൂടുതലുള്ള ഏതാണ്? അലുമിനിയാണ്. So according to our rule, higher the charge, polarizing power is higher. Smaller the size, polarizing power is higher. Higher the polarizing power, higher will be what? Covalent character. Higher the covalent character, melting point will be what? Less. So which one have less melting point? See, AlCl3 have lower melting point than MgCl2, lower melting point than NaCl. NaCl have higher melting point. Another example, see, beryllium chloride, BeCl2, MgCl2, CaCl2, SrCl2, BsCl2. Beryllium chloride, magnesium chloride, calcium chloride, strontium chloride, barium chloride. In all these cases, anion is same. Cation is what? Beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, barium 2 plus. Okay, so down the group, this belongs to second group. താഴേക്ക് വരുന്തോറും down the group, size of the cation increases. Higher the size of cation, lower the polarizing power. Lower the polarizing power, lower the covalent character. Okay, covalent character കുറവാണ്, lower the covalent character, melting point will increase. So which one have higher melting point? This barium chloride have what? Higher melting point. So the order of melting point is BaCl2 greater than SrCl2 greater than CaCl2 greater than MgCl2 greater than BeCl2. Okay, so this is another example. Next, you can see here. Next, another example. Listen. Another example. MgF2, CaF2, CaCl2, CaBr2, CaI2. See, all are calcium. So cation is same. Check anion. Fluorine minus, chlorine minus, iodine minus. Size of anion what? Increases. Iodine is what? Higher. Higher the size of anion, higher will be the polarizability, higher will be the covalent character. So which is more covalent? Ca(I2) is more covalent. This is more covalent. This is more covalent. Okay. So the covalent character Ca(I2) high. Higher the covalent character, lower the melting point. So which one have lower melting point? So melting point order Ca(I2) less than Ca(Br2) less than CaCl2 less than CaF2. Okay, ഇത് എന്താണ്? കോവലന്റ് ക്യാരക്ടർ ആണ്, ഇത് മെൽറ്റിംഗ് പോയിന്റ് ആണ്. Okay, clear. Next another example. See, SnCl4 is a volatile liquid whereas SnCl2 is solid. SnCl4 is a volatile liquid and SnCl2 is a solid. Why? Because here -1, here +2, here what? +4. Higher the charge of cation, higher the polarizing power, higher the covalent character. Higher covalent character, melting point decreases. Melting point decreases. Melting point decreases means what? It is a volatile liquid. That means it is a liquid already is what? Molten. It is a liquid. This one is what? Solid. Okay. So covalent character higher for this one. Covalent character. Okay. Melting point. Melting point SnCl4 what? Less than SnCl2. Melting point. Order of melting point. Okay. Next one. Another example. PbCl2, PbCl4, lead chloride, lead tetrachloride. Okay, so here again what? Melting point, I mean covalent character higher for this one because it is what? +4. Here it is what? +2. Covalent character higher for this, but melting point what? Lower. Higher the covalent character, lower the melting point. Another one more example we can have, that is NaCl and CuCl. NaCl and CuCl. NaCl and CuCl. Here what? +1, here +1. Both are +1. But this one have what? Pseudo noble gas configuration. Pseudo noble gas configuration. Pseudo noble gas configuration. Higher the polarizing power, higher the covalent character, lower the melting point. So melting point order CuCl have low melting point. Low melting point. CuCl have what? Low melting point than what? NaCl. Covalent character NaCl what? Less than CuCl. Okay. This is what? Covalent character. This is what? Melting point order. So that is the first application, that is melting point. Next is second application. Solubility in water. Okay. Higher the covalent character, okay, lower the solubility in water. Higher the covalent character, lower the solubility in water. We know that ionic compounds are generally soluble in water. When the ionic character decreases, that is covalent character increases, solubility decreases. So higher the covalent character, lower will be the solubility in water. Okay, we can have some example. See, FeOH twice and FeOH thrice. OH thrice. These are two examples. See, Fe is what? +2, Fe is what? +3. Here it is what? -1, anion same. Okay, so we can predict based on what? Cation, because cation charge is what? Different. Here higher the size of, I mean charge of cation, higher the covalent character. Higher the size of cation, higher the covalent character. Okay, so the order of covalent character, this is the order, covalent character order. Higher the covalent character, solubility will be what? Less. Okay, so solubility order FeOH twice will be more soluble than what? FeOH thrice. Solubility order. Okay, this is the solubility order. One more example I am giving. See, Ag2O and Ag2S, which is more soluble in water. See, here what? Sulfate ion minus, here minus. Oxidant. Both negative anion and cations are what? Same charge. Silver is the cation. Both cation and anion charge is what? Both anion charge same. Both cation charge same. Then we can predict by checking the size. See, what is anion here? Oxygen. Here anion is what? Sulfur. In 16th group, we have oxygen and sulfur. Sulfur is what? Bigger than what? Oxygen. So size of anion bigger. Higher the size of anion, higher will be the polarizability, higher will be the covalent character. So covalent character, this one. Okay, covalent character, this is the order of covalent character. Higher the covalent character, solubility will be what? Less. So solubility order Ag2O is more soluble than what? Ag2? Yes, solubility order, solubility order. Okay, so this is the second application of what? This Fajan's robe. Next application, color imparting character. Okay, color imparting, that means higher the covalent character, darker will be the color, darker, that is it will be what? More colorful. Okay, that means color imparting character, color what? Increases. Higher the covalent character, color imparting character increases. We can have an example: AgF, AgCl, AgBr, AgI. All are Ag plus 1 plus 1 plus 1 plus 1. Cation same. So we can predict based on what? Anion. F minus, Cl minus, Br minus, I minus. The charge of anion also same. Then we can check based on what? Size. So which is bigger in size? Added is what? Bigger in size than what? Br, than what? Cl minus, than what? F minus. Higher the size of anion, higher is the polarizability, higher the covalent character. So covalent character, this is the order of what? Covalent character order. Higher the covalent character, higher, that is color imparting character also increases. So color also what? The same order. Color also same order. We know that this one is what? Dark yellow. This one is what? Yellow. This one is what? White. This one colorless. Okay, that means higher the covalent character, higher the color imparting character. From colorless, it is coming to what? Dark yellow. It's okay. Okay. Next, one more example we can have. See, one more example. We know that PbCl2 is colorless, but PbI2 is what? Yellow. Because Pb plus 2 minus 1 plus 2 minus 1, cation same, charge of cation also what? Same. Anion charge is same, but anion is different. Here is chloride ion, here what? Added ion. Which one is bigger? Added ion is bigger. Okay, so higher the size of anion, higher the covalent character here more. It's okay. So higher the covalent character, then color character also in the same order. PbI2 color is what? Yellow. This one PbCl2 colorless. Okay, so these are the applications of what? This covalent character in ionic compound. Now what we discussed, we can summarize. So in ionic compound, there are some covalent character. This covalent character depends on the polarizing power of cation and polarizability of anion. The polarizing power of cation inversely proportional to the size of the cation. That is, cation size decreases, polarizing power increases. Polarizing power of cation again directly proportional to charge of cation. Now polarizability of anion is directly proportional to charge of anion. Polarizability of anion again directly proportional to size of anion. Similarly, now melting point, I told you that higher the covalent character, that is lower the ionic character, then melting point what? Decreases. So melting point inversely proportional to what? Covalent character. Similarly, solubility, higher the covalent character, lower will be the solubility. So solubility again inversely proportional to what? Covalent character. Color imparting nature, that is directly proportional to what? Covalent. Next we can do some problems based on this. Okay, so calcium oxide and magnesium oxide, which is more covalent or which is more ionic? That is the question. See, first question, calcium oxide, CaO MgO, -2, anion sign, anion charge also same. Calcium +2, magnesium +2, both are same. Now size, magnesium, calcium, both belongs to second group. Calcium comes below magnesium, so which is bigger in size? Calcium is bigger in size. Magnesium is smaller in size. Smaller the size of cation, higher the polarizing power, higher will be the covalent character. So MgO is more covalent than what? CaO, or CaO is more ionic than MgO. That is first question. Next, Mn, second question, MnO2 and MnO4, -2, anion same, anion charge same. Then Mn +4, Mn +2. Higher the charge of cation, higher will be the polarizing power, higher will be the covalent character. So MnO4 is more covalent than what? MnO2. Next, K2CO3, CSCO3, which is more soluble in water. Solubility, we have to check the solubility. K2 potassium carbonate or calcium carbonate. See, K2CO3, CaCO3. See, CO3 -2, CO3 -2, anion same, anion charge is also same. Here what? +1, here +2, +1, +2. Higher the charge, higher the polarizing power, higher the covalent character. Higher the covalent character, lower will be the solubility. Higher the covalent character, lower will be the solubility. So which is more soluble? Potassium carbonate is more soluble than calcium carbonate. Potassium carbonate is more soluble than calcium carbonate. Next, NiCl2 and CaCl2, NiCl2 and CaCl2, CaCl2, -1, +2, +2. Here what we have to check? See, here transition element came. In case of transition element, generally covalent character is higher than S block elements, first and second group element, because in case of transition element, poor shielding of d and f orbital, the outer electrons are not easily participated in ionic bonding. അതായത് poor shielding of d and f ഉള്ളതുകൊണ്ട് ഔട്ടർ ഇലക്ട്രോൺ വളരെ പെട്ടെന്ന് എന്ത് ചെയ്യില്ല? അയോണിക് ബോണ്ടിങ് എന്ത് ചെയ്യില്ല? ഇൻവോൾവ് ചെയ്യില്ല. അതുകൊണ്ട് അയോണിക് ബോണ്ട് ഫോം ചെയ്യാനുള്ള ടെൻഡൻസി കുറവാണ്. ഇറ്റ് മീൻസ് ദിസ് ഇസ് ആൻ അയോണിക് കോമ്പൗണ്ട്, ബട്ട് ആസ് കമ്പയർഡ് ടു ദിസ് കോമ്പൗണ്ട്, the ionic character will be less, that is covalent character will be what? More. Transition element ionic compound form ചെയ്യുന്നുണ്ട്, പക്ഷേ അതിൻ്റെ poor shielding of d and f orbital ഉള്ളത് കൊണ്ട് ഔട്ടർ ഇലക്ട്രോൺ അയോണിക് ബോണ്ടിൽ പങ്കെടുക്കാനുള്ള ടെൻഡൻസി മറ്റ് എന്താണ് ഫസ്റ്റ് ആൻഡ് സെക്കൻഡ് ഗ്രൂപ്പ് എലമെൻസിനെ അപേക്ഷിച്ചിട്ട് എന്തായിരിക്കും? കുറവായിരിക്കും. ദാറ്റ്സ് വൈ ദിസ് അയോണിക് ക്യാരക്ടർ ലെസ്, ദാറ്റ് ഈസ് കോവലന്റ് ക്യാരക്ടർ മോർ. സോ NaCl2 is more covalent than what? CaCl2. Next one, N2ClF3 K2O LiF, which is more covalent, arranged in the increasing or decreasing order of what? Covalent character. N2 both atoms are what? Similar. All homodiatomic molecules are but non-polar, highly what? Covalent. So this is highly covalent. Next, ClF3 ionic or covalent? See, remember one thing, when a metal and non-metal combine, it will be what? Ionic. Metal and non-metal combine, it will be what? Ionic. Two non-metal combined together, it will be what? Covalent. It will be covalent. So here in ClF3, chlorine is metal, fluorine is also what? Metal. Two non-metal, so it is covalent. But in this covalent, two different atoms are there, so there is a partial what? Polarity. So little ionic character will be there. So as compared to N2, ClF3 is what? More ionic. ClF3 will be more ionic. So N2 is what? More covalent than what? ClF3. Next, now in case of LiF and K2O, we know that Li is plus 1, K is what? Plus 1. Both are what? Plus 1. It's okay. Now, if charge of cation is same, then we have to check what? Size. Li have what? Smaller size as compared to what? Potassium. Okay. So, smaller the size, higher will be the polarizing power. Higher will be the polarizing power. Okay. Higher the polarizing power, higher will be the covalent character. So, which one will be more covalent? LiF will be more covalent. LiF. Then least covalent will be what? K2O. K2O will be what? Least covalent. It's okay. So, this is what? The order of what? Next, the last problem. AlF3, Al aluminum fluoride, aluminum nitride, aluminum oxide. Arrange in the increasing order of their covalent character. So, here see aluminum plus 3 is there. What are the anions? F minus is there, then N3 minus is there, then O2 minus is there. Which is bigger in size? Okay, so this type of species are called isoelectronic species. F minus fluorine atomic number 9, F minus total number of electron 10, nitrogen atomic number 7, N3 minus total number of electron 10, oxygen 8, total number of electron O2 minus will be what? 10 electron. So, in isoelectronic species, remember, for example, Na plus, Mg2 plus, Al3 plus, next one N3 minus, O2 minus, F minus. These are isoelectronic species. Now, in isoelectronic species, if it is cation, higher the charge, smaller will be the size. Higher the charge, smaller will be the size. So, the size of here up to here the order will be what? Na plus bigger than Mg2 plus bigger than Al3 plus. This is the order of size here. Okay. Now, in case of anion, higher the charge, bigger will be the size. Higher the charge, because electron repulsion will be there. Okay. In case of cation, higher the charge, smaller will be the size. In case of anion, higher the charge, bigger will be the size. So, which one will be more bigger? N3 minus bigger than O2 minus bigger than F minus. It's okay. Remember, this is called isoelectronic species. In all these species, total number of electrons is what? 10. So, here we have isoelectronic species. All are anions. Then higher the charge, bigger will be the size. Okay. Higher the size of anion, higher will be the polarizability, higher will be the covalent character. So, which one will be bigger in size? We have what? Al, N, then another one Al2, O3, another one Al, F. Here what? Minus 3, here minus 2, here minus 1. Which is bigger in size? This one is bigger in size. Cation all are what? Same. Cation all are what? Same. Then anion bigger in size is what? Nitrogen. Okay. So, higher the size of anion, higher will be the polarizability, higher will be the covalent character. So, which one will be more covalent? Aluminum nitride is more covalent than aluminum oxide, which is more covalent than aluminum fluoride. Aluminum fluoride. Clear? It's okay. So, these are the application, examples from Fajan's rule. Okay. Now, we know that most of the salts of lithium are what? Soluble in organic solvent, not in water. The reason? Because it is what? Covalent character is what? High. Okay. Pronounced covalent character. Higher the covalent character, solubility decreases. Okay. Thank you.